Good morning, all. Myself Poornima, and I'm a student pursuing in Global Academy of Technology. And my co-authors are Likita H, Suraksha, Bhuvan Gowda, Satyanarayan. And today I'm mainly going to discuss on the topic of a sustainable approach of ground improvement technique using Geogrid encased stone-filled column with a coconut shell chips. And this is purely going to be an experimental study. So as we all know that the ever-growing demands of the urbanization and the industrialization have been giving the necessities for the development of innovative and the sustainable solutions for the ground improvement in the Department of Civil Engineering. So the ground improvement technique plays a vital role in this concept, in which the bearing strength and the settlement characteristics are going to be increased. To evaluate the performance of this sustainable ground improvement technique, a comprehensive experimental study was designed by us and it was executed in an experimental way. In this investigation, we came to an conclusion that the sustainable development was very much necessary for this urbanization and industrialization. And nowadays, due to the space constraints and very limited time, the engineers have a very good thought of completing the work in a well designed way, and for this the soil profile may not be suitable for the construction. In such cases, the introduction of stone column could be made, and the main purpose of this work was to analyze the construction and the behavior characteristics of a geogrid encased stone filled column. And in this, the shear strength, loading capacity, and the bearing strength was very much increased, and the settlement of the soil was also controlled in that. So coming to this study, we got a previous studies and the literature surveys done, in which the certain authors had already given certain findings and the descriptions. Based on that, we took certain characteristics which were necessary for our project to continue, and then we continued with that. Coming to the first paper that was published by the IGS, the interaction mechanism between the stone and the geogrid was used in that project. So we got to know that usage of geogrid could be a better suitable option for this generation. And then coming to this paper, which was published by IGIR-SCT, we got to know that they had performed this stone column in a black cotton soil. But we were supposed to do it in a clay medium so that it could be suitable in all the areas where the loose soil or the granular soil are especially seen in that places. So for this, we collected certain samples, that is the aggregates which were of 20 mm and below down size, and then M sand, soil, geogrid, coconut shell. We used M sand instead of river sand so that it could be economical and sustainable too. And the geogrid we used was biaxial BX geogrids. And then the soil was of the clay medium, and the coconut shell, which is a natural fiber. And then coming to the process, first we collected all the samples, and then certain tests were conducted on the samples. And then we prepared the model, and then the test on the model was done. Then the observation result and the conclusions were noted down. So the tests which were conducted on the materials were on the coarse aggregate, that is the stone. We calculated specific gravity, which was around 2.56, bulk density. In the compact, it was 1.5 kg per meter cube, and in the loose state, it was around 1.3 kg per meter cube. And the crushing strength was around 28.9%, which was actually good. And the bearing capacity could increase due to this. And the impact value of the stone was around 13.616%. And then coming to the M sand, we performed only two tests, that is the specific gravity and the moisture content. The moisture content was around 13.63% and the specific gravity was 2.21. Conducting these two tests were well specified for M sand, because to have the less water content in M sand could give the strength more. And then coming to the soil, that is the red soil we used in this case. The plastic limit of the red soil was around 17.88% and the liquid limit was around 35%. And we calculated the liquid limit using the cone penetration method, which could give the accurate value of the liquid limit. So coming to the process, First, we took a cylindrical tank which was made up of mild steel, as you can see in the picture. And the diameter of that tank was around 30 centimeter and the height was 28 centimeter. So first, we calculated the volume of the tank, and then which came up around having 1,800. And for that, approximately 32 kgs of soil was supposed to be compacted in that. So we weighed the 32 kgs of soil. We mixed with some water that is of 3% of the water given by the OMC and the MDD standards. Based on that, we took 32 kgs and then we compacted the entire soil into that tank. And in the first case, we took the ratio of 1:3. That is where one part of M sand was used and three parts of stones were used. That is the coarse aggregate. You can see in the picture that there is an hollow cylindrical place in which the sand, and that is the M sand, and the stones were compacted thoroughly into that. And then the entire setup was placed in an UTM machine. And then the load and the deflection was obtained from the setup. And from that, we got to know that the stone column placed in that could take around 1.82 kilonewton, and after which it starts to fail. So we went to a next case in which one part of coconut shell and two parts of M sand and three parts of stones were mixed and then compacted thoroughly, and then the same process was repeated. In that, we came to a conclusion that 3.9 kilonewton of the load could be taken by that particular stone column. So basically in this, the height of the stone column was 23 centimeter and the diameter was 10 centimeter, which was the standard value. And then coming to the results, both the trials actually satisfied the main aim of this project, that was to increase the bearing capacity and improve the ground strength economically, in which the case one clearly said that the maximum deflection that the stone column model could withstand was around 1.82 kilonewton, and the trial 2 could take off about 3.59 Newton, which exactly said that the trial 2, that is the coconut shell, using the coconut shell, the stone column could withstand more strength. And this also said that coconut shell adds as a natural fiber to it, and it also prevents the friction between the M sand and the stone aggregates what we have used in that. The main usage of M sand in this project was to completely clear the voids so that the strength attained could be more. Yeah, thank you.